What happens when a restaurant built on an old barge starts to leak through its rusty hull and begins to sink? Highly specialized construction workers known as commercial divers must be brought in to patch the leaky barge using a technique known as underwater welding. Underwater welding is similar in process to stick welding on dry land, except the underwater rods have special additives in the flux that cause the molten weld to cool at a slower rate than it normally would underwater, which allows time for gases trapped inside of the molten weld to escape, preventing porosity throughout the welds. Rods must also be dipped in a thick coat of wax to prevent corrosion to the rod before being used. Currently, stick welding is the only commercially available welding method for use underwater. There are AWS standards for underwater welding, but due in part to the lack of underwater welding inspectors, these are rarely used for most common inland marine construction projects. Performing these underwater welding repairs in situ is much more efficient than hauling out a barge to a dry dock, saves a tremendous amount of time, money, fuel from towboats, which in turn reduces greenhouse gas emissions. Despite the protective barrier of the water, a welding shield is always used while welding underwater to protect the diver's vision. A thick wetsuit and 2 pairs of specialized gloves help protect the diver from being shocked while welding underwater, although it never seems to completely mitigate the hazard, as even a tiny hole in the elbow of a diver's wetsuit can allow painful muscle spasming shocks into the diver's hand and arm. These small shocks, while incredibly painful, are usually harmless and something an underwater welder must get used to as part of the job. You'd be hard-pressed to find a more deadly profession in the construction industry than underwater welding. The first of many important safety considerations with underwater welding is the exclusive use of DC, direct current welding machines, utilizing reverse polarity, where the positive is the ground, so that the flow of electrons travels away from the diver's body and the electrode he holds in his hand. AC welding machines should never be brought onto underwater welding job sites, as this type of welding current is highly erratic in its behavior underwater. AC current flowing through water can almost instantly send a diver's heart into painful heart attack-like arrhythmias, typically followed by cardiac arrest and then death, similar to that of the executioner's electric chair. There's another even deadlier hazard in the buildup of explosive hydrogen gas that forms through the electrolysis reaction from the arc created in the welding process that separates the water molecules into hydrogen and oxygen atoms. If this hydrogen gas is not properly vented to the free atmospheric surface and is allowed to build up in a pocket near the diver, small welding slag embers still smoldering underwater can make their way to that hydrogen pocket, ignite the gas, and cause an explosion, in some cases so powerful that it shatters the bones and ruptures the organs of the diver, killing them instantly. The diver's success hinges on the support he receives from the crew topside. Typically, in support, there are crane barges, boats, large barge spreads with all the necessary supplies and equipment. Structural steel used in underwater welding is manufactured by a process called hot rolling, where molten steel is poured into billet shapes. After cooling slightly, the billet is run through a series of rollers that gradually squeeze it into the desired section. This process is governed by ASTM A1011, the specification for high-strength hot-rolled steel. While work is done by the machines, the environment can be extremely hot and loud. Extensive PPE is typically required to work in these conditions. As the rollers wear over time, it can become loose and no longer meet the tolerances required to meet ASTM standards. Also, the steel can develop ridges, bumps with these rollers that are not acceptable. Sustainable practices currently in the industry include advanced recycling of scrap and techniques to reduce fuel consumption in the blast furnace. In summary, underwater welding is a process that relies on complex interactions while maintaining the safety of all parties involved. As a result, there is at least one person who is a standby diver at all times, meaning there is a lot of time spent waiting. This is an important function that increases cost, but ensures that the project can be completed safely.